o'clock. Again, similar to yesterday, we'll have lunch break. There won't be any scheduled afternoon break, but we will have coffee in the afternoon if you want to sneak out and grab that. If you have any questions, come find me. Otherwise, I will hand it over to Ben to tell us about React Fiber.
All right. Thank you very much. All right. Good morning, everyone. Oh, yeah, I was worried about that. Okay. It's 9 a.m. on a Sunday. We had a party last night, yeah. But don't worry, I have something for you to wake you up, so don't worry about that. But yes, I'm here to talk about React Fiber, React 16, and but I don't want to focus on the technical implementation of React Fiber and how that works and all the nitty-gritty details. Instead, I want to focus on how does React Fiber affect how we build our applications, how we write them, what will it do for those applications. So just to let you know, I tweeted out a link to my slides. So if you go to BenMVP, to my Twitter account, actually, no, I forgot to tweet out a link to my slides, now that I think about it. But if you go to my website, benmvp.com, it's up there already, and I'll tweet out a link after the talk. So since it's early in the morning, right, and we're trying to wake up and such, I have an idea. So I want everyone to stand up with me. Can I get everyone to stand up? Can I get everyone to stand up? Okay, so yes. So what we're going to do is that we're all going to do 10 squats like this together, okay, in unison, just like this. We'll do it all together. I'll count it out so we can have lots of fun and such. If you're not physically able, that's okay. You can just stick out your arms or whatever, but it's just a way for us to get the blood flowing so that you don't fall asleep during my talk, basically. Okay? So I'll count out the 10 squats and then we'll be done, okay? So ready? Here we go. 1, there you go, yeah, 2, 3, didn't think you were gonna be doing this, huh? 4, 5, people are walking in like, what? 6, 7, 8, almost there, 9, and 10. Nicely done, nicely done. Right before you sit down, I want you to turn to your neighbor, introduce yourself, and say good morning as well, okay? All right. So, what you don't realize is that I kind of tricked you. So, out of this, at the very least, you're going to get 2 things out of this talk, right? You got an early morning exercise, and you got to meet some people you didn't know. So, hopefully those will be more than those 2 things, but you at least got those 2 things. So, introducing myself formally, my name is Ben Elegbadu. I'm a Christian, a husband, and a father. This is a picture of my wife and my 2 daughters. So my wife Rashida, we've been married a little over 7 years, and those are our 2 daughters, Simone and Avery. Simone is 3.5 years old, and Avery is just a little over a year. And I promise Simone and Avery actually like each other. The picture doesn't suggest that. I actually think she's looking at me funny, not Simone funny, which would make way more sense. But yeah, we live out in Pittsburgh, California. So not Pittsburgh, Pennsylvania, Pittsburgh, California. There's no H at the end of it. It's about an hour outside of San Francisco. So I commute into the city every day to work at Eventbrite. But I'm also a huge basketball fan. I love playing basketball. I love watching basketball, particularly the NBA. And I'm from Houston, so my favorite team is Houston Rockets. I love watching them, and hopefully this is the season for them. But my favorite moment, since I'm in Boston, my favorite moment about the Boston Celtics is this moment right here. Now, I know that the intersection of people who love React and the people who love basketball, those don't really intersect much, right? But if you know this moment, this Boston Celtics moment, I want you to come up and tell me or tweet me or whatever, because this moment is hilarious. I'm not going to describe what it was, but yeah, if you know it, that means you're like a true fan, or that you would train boot camp grads, all the front-end boot camp grads, for about 3 months, 4 months, kind of teach them about front-end development, teach them about how we build front-end at Eventbrite in general, and then we would send them off to the actual feature team so they could like be awesome for those teams instead of just throwing them out to the wolves in the beginning and having a kind of sink or swim mentality. So she was with us, trained, and then went off to her team, and she ended up leading one of the teams, just like some of the other ones who were part of the program, and was able to really be awesome. And now she's kind of like coming back full circle, coming back to the front end team, and her and another boot camp grad, they're basically in charge of our front end infrastructure and making sure that they can push us forward. And well, the reason I share all of that is one, to like completely embarrass Kaylee, and looking at her face, she's definitely embarrassed. But secondly, just to kind of highlight the fact that you don't need a CS degree from a four-year college to be awesome at what we do, right? It's not to put down CS degrees, because I got one and I'm proud of it, but there's this mentality that you have to graduate from MIT or Stanford and get a CS degree to be able to do what we do, and that's proving not to be the case. Like, I used to believe that was the case, but folks like Kaylee and other people at our company have proven that that's not the case. So if you are one of those people who graduated from a non-traditional background or have a non-traditional background, and I want you to kind of feel inspired by what Kaylee's been able to do, what other people have been able to do, and realize that you can do it, you can be awesome. You're just not relegated to the bottom. Like, you can lead teams and go to conferences and speak about tough technical topics. And then for all of us, all of you who are in kind of positions where you can make hiring decisions or you can influence hiring decisions, don't just kind of narrow your view to those who have graduated from CS degrees. Like, open it up. You can see people who are going to be able to do the same amount of things that everybody else can do, or maybe even better. So yeah, I just wanted to go out next week. At least that's what they shared when they changed the license over to MIT. So taking a quick look at it, so the stack reconciler is kind of the current reconciler that exists in version 15. So when you're rendering something out and you do a set state, it renders into a completion. So if you had this huge nested tree, or you had a whole bunch of complicated logic in order to render this tree, you could spend so much time rendering your UI that the experience looks sluggish, or the JavaScript engine doesn't have control of things for a very long time. So you're kind of sitting underneath this rendering structure. So most of the time this is fine. We're not doing anything that complicated, so it works okay. But if you have something that's really, really big, it can feel like your UI is sluggish because things aren't responsive. Contrast that now with the Fiber reconciler, which periodically gives control back to the JavaScript engine so that it can see if there's something that's more important that needs to be rendering. So like asynchronous requests, when you're making an API request, because it's going out to the server and coming back, that doesn't necessarily need to be rendered right immediately. You can have some delay that way. So if you were typing in a field and you got a request that was rendering out a whole list of results, like while that list of results is rendering and you type some more, you want that feedback when you're typing immediately, whereas the results can slowly come in. And the result of this is that you get a higher perceived performance. So there are various levels of update priorities. You have the synchronous priority, which is basically what happens now with the stack reconciler. You have task priority, which means that at the next tick, this thing needs to be rendered. You have animation priority, which means next request animation frame, this thing needs to be rendered. High is something that's just of importance, like typing. Low would be like an API request response. You would want that to be low. And then something that's off screen, of course, is the lowest priority. It doesn't even necessarily need to be rendered right this moment. It's just being prepared to come in on screen. So that's really all I want to say about the technical side of Fiber, because Lynn here at ReactConf earlier in March did an amazing job diving through React Fiber and how it all works. The React team has released what are called code mods that will change your code automatically for you. So if you run the prop types code mod, or you run the class transformation code mod, then it'll change all your code for you, so you don't have to manually do it. So I actually ran it on one of our design system at Eventbrite, and it ran fine. There are other problems with upgrading to 16, but that part was okay. Webpack issues. But yeah, I know. I know. So I'm assuming that kind of pulling out prop types, pulling out create classes, what helped that 25% reduction in the library side. Okay, let's talk about the next thing. Let's talk about custom attributes and the changes that have happened with those. So in React 15, any unknown attribute that you put on a DOM element would be stripped from the markup when it got rendered out. So here I have this SVG, I'm putting on foo equals bar. React doesn't recognize that, so it will strip it out in the rendered HTML. And it would give me a warning saying, hey, this foo prop is unknown. You shouldn't add it in there. And the reason for that was because they were trying to protect from cases where we were just randomly spreading props into elements and forgetting that those aren't supported. So they want to kind of let us know that those problems were happening. But the problem with that is that React had to maintain a whitelist of all of the properties, all of the attributes for every single HTML element that exists. And it was a growing list of those properties in order to support this feature. And they're always going behind, especially with SVG features. If you look at the commit logs or the change logs for React, every time they had a release, they had to add this new prop or this new attribute for SVG or this tag because it was unsupported. So now custom attributes are supported in React 16. So if you do put your own custom attribute on a tag, for instance, the foo bar on it, it'll actually put it there in the markup. And custom attributes are useful because like maybe there's some browser-specific, vendor-specific attributes that need to be on tags that React doesn't know, or there's new APIs that are coming out that React hasn't caught up with, or third parties require some attribute that needs to be there in order to interact, those sort of things. And there were legit cases. So now custom attributes are supported by React 16. And they're able to greatly shrink that whitelist that they had to maintain. And that also contributed to the package size being smaller. So now you have the case where you may accidentally pass in some props that you didn't expect, and it would actually get rendered into the markup. But React still has some helpful warnings for you. So let me kind of walk through these various cases. So it knows to look out for class, because that's like the biggest issue that we accidentally make, using class instead of class name. So for those of you who are not aware, React models the JavaScript DOM API for its properties. That's why it's class name or HTML4 instead of class and for. Because if you get a DOM element and you want to set the class name, or you want to set the for on a label, it's going to be class name or HTML4. So if you do a div and say class equals foo, it's going to give you a warning and say invalid DOM class, did you mean class name? Now, it'll still render out the class, but it'll give you that warning. Similarly, if you did class name in all lowercase, not the camel case, it'll give you a warning saying that that was an invalid property. Did you mean class name? But it will render out class name in all lowercase. If you left off the E, for instance, and did the camel case and had class nom, I guess I'll call it, and misspelled it, it will give this kind of nice detailed warning that says React does not recognize the class nom prop on a DOM element. If you intentionally wanted it to appear as a DOM element, as a custom attribute, spell it with lowercase instead. And if this was an accident, just remove it. However, if you have an all lowercase prop and you misspell it like class with one S or class nom all lowercase, then it'll just go through because it's assuming that you're trying to use a custom attribute. So something to look out for. You may accidentally start rendering things out. So if you're having warnings right now with your custom attributes, I suggest you clear them up right now. Okay, let's move into the next one. Let's talk about return values. Hopefully some people will be happy about this. So if you're new to React and you're just getting started and coming from a typical templating background, you may try to do something like this, where you have this page component. It has an H1, and then as a peer to that H1, you want to render out this page body. And the page body has an aside and a section, just random things. So essentially, you want to put that aside and that section inside of page such that they will be siblings of the H1. And maybe you want to do this because you have some flexbox styling you want to do, or, I mean, that just logically makes sense for them to be siblings of each other. But if you do this, you're going to get this error, and it fails to even compile. It's like not even valid JavaScript, and it tells you that adjacent JSX elements must be wrapped in an enclosing tag, which is sad because now you have to stick a div around it, and you have all of this code in your code base that just has empty divs, empty spans, or whatever. Our Eventbrite design system has a whole bunch of just divs that are there just for the purposes of enclosing content, and I'm sure all of your apps have the same. And the problem is that this breaks Flexbox. Like you just no way to solve it because you're encapsulating it in a tag. So adjacent JSX elements are still invalid in React 16. However, returning arrays from components is now valid. So now you have the ability to actually make those siblings by, instead of returning a container, you wrap those two elements in an array and return the array instead. So in this example now, we have the aside being the first element of the array, the section being the second element of the array, and then now they'll actually get stuck in as siblings of the H1. So our UI, our markup is rendered like we would expect. The only downside, well, I see two downsides really, is that we're now mixing up this kind of static markup with an array syntax, which is a bit weird. And because it's an array, we still have to specify the keys. So even though it's static, it's not a dynamic loop, we still have to specify the keys. So I have kind of key aside, key section there. Because otherwise I would get the key warning. So trying to figure out a way that we could avoid that, because this is kind of funky. There's this new kind of idea called self-eradicating components, or self-eradicating component. So you wrap the aside and section in this, what's called an aux component, and all the aux component does is just return the children back to you. But now now that React 16 supports arrays and props that children is an array, this actually works. If you tried to do this in React 15, it'll throw an error and say you can't return arrays. So now, even though it looks like you're still putting an enclosing tag around the contents, like we had a div before, except now it's an aux component that doesn't render anything. It just renders out the children. So in the end, those children will be siblings of the H1, and then your Flexbox and everything can work well. So that library I listed at the bottom, React aux, the library, all it contains is this one component, this one line of component in there, right? And the rationale was that if you see it then in your code, then you'll go and read the documentation and understand why it exists. But now that you know how it exists, you can just write this aux component yourself in your code and not have to have another node module. So I think this is kind of a cool way to kind of solve the problem that we're seeing with static content. But in general, when you're using arrays, you're going to be mapping over something and returning it, so that'll work perfectly fine in your components. So also strings are valid return values too. You probably won't run into this too much. The only real use case I could see for it is like a localization component that you can use so that you can pass in a message, pass in some tokens, pass an arbitrary markup, and have it return the value. So it's basically having a declarative syntax wrapped around a function for you there. But other than that, I couldn't find any real use cases. But you can also return Booleans, you can also return numbers from components as well, if you have a need for that. Okay, so we've talked about the changes in React packages. We've talked about custom attributes. We've talked about these new return values. Now let's talk about handling errors. Handling errors gracefully, not like her. Okay, so if you have a component now in React 16 and an error happens in that component, your entire app is going to be unmounted. Your screen is going to go blank. There's going to be no more app if an error happens. This is contrasted to what happens now, where you have basically a broken app if an error happens. Maybe you can click some parts, maybe you can't click other parts, and it's kind of this broken experience, even though visually it looks there. And the React team kind of debated whether or not they wanted to do this, because this is a pretty big drastic change. But the rationale for them was that a broken app is a pretty bad experience. Like imagine our checkout flow, if we had an error happen and maybe somebody could buy something for free or steal a credit card or something like that. We don't want those kind of situations to happen. So the safest bet is just to unmount the entire app. But now when errors happen, they have a better error messaging that happens. So it'll actually tell you in what component that the error happened, and it'll show you the whole component hierarchy, so you can actually know where it happened instead of saying some like react_children.js file that you have no access to. So that's pretty helpful. Yeah, we can clap for that. Clap for that. I know you're clapping for the team and not me, but I'll take it. Don't worry. But in the messaging, I don't know if you can see this. It's pretty tiny. But it says something about, oh, there's an error that happened. Why don't you try using an error boundary component? And Sasha alluded to these error boundary components yesterday when he was talking about server-side rendering, and that server-side rendering doesn't support it, but client-side rendering does. So let's talk about it and what they enable us to do. So now there's this new lifecycle method called component did catch. So like you had component did mount, you had component will unmount, component did update. There's now component did catch. And this method is going to be called anytime an error happens further down in the component tree. And it'll bubble up to this component. You'll get the error that happened and then additional error information. So like the stack trace and the line numbers and that sort of thing. And what you can do now with that is that you can create an error boundary component that uses that component lifecycle. So you can have some state that says has error false. Now that's the default. And then in the render, when there's no error, you just render out the children like normal. And now because components can return arrays, you can actually return the children like we learned. But then if an error does happen, it's going to call the component did catch. You can then set the state to has error to true. And on the side, you can actually notify your JavaScript error reporting system. So at Eventbrite, we use something called Bugsnag for all of our JavaScript reporting. And it's let us know about all of our errors that we do have. And we notify that. Then when has errors turn to true, as you know in the true React form, it comes back and renders. And now when it renders, it's true. And then you can give a message to the user that something went wrong. Hopefully you would have something more sophisticated than my example that I've shown you here. But that's kind of the gist of how it works. So an error boundary component works like any other component. You can just nest whatever components within it. And if any error happens in those components, it gets bubbled up to the error boundary and it handles it. Now I should know that if an error actually happened in the error boundary component, then it won't handle it itself. It'll bubble up higher in the tree. So if you didn't have anything else higher in the tree to handle it, then your whole app will get unmounted. So what's suggested then is to wrap an error boundary component around your entire app, basically, around your entire routes, so that if anything happens anywhere in the route, you can handle that error boundary. And now this is basically a way for us to do kind of the typical server-side 500 errors when something happens and you return an oops page to the user. You can now do that on the client without actually having to go to the server. So now we can have those type of helpful error messages. But the nice thing about doing it this way is that you can still have your typical nav that's at the top of the page or the left side of the page, render. But then if an error happens in the actual route where the logic is, then you can display something there for them to know that something went wrong. They should refresh the page or something like that. So you can use error boundaries on a small scale, like let's say just in a certain section of your site. But it's always suggested, or they suggest that you use it around the whole page as well so that your whole app doesn't get unmounted. Okay, now let's talk a little bit about server-side rendering. Sasha really went through all of it yesterday, a lot of it, so I'll kind of cover it as quickly as possible. But in my opinion, server-side rendering is kind of the killer feature, another killer feature of React. Most other JavaScript libraries, or at least before it, didn't allow you to render server-side because they touched the DOM specifically. Because in React, we're building up components in a render, not building up strings, we're able to then, on the server, take those components, use render to string, and then come out with an actual string that we put in the HTML response. So as they mentioned yesterday, as Natalie and Sasha mentioned yesterday, rendering server-side is good for performance, initial performance, as well as SEO. So if you've ever looked at the markup of server-side rendering code with React 15, there are all these data-React IDs in the markup. And we have gzip, it gets gzipped, so it's shrunk a little bit, but it's still extra code that's in the markup, and it increases the size of it. And those data-React IDs were used basically so that React, when it renders on the client side, could correlate what happened on the server side so that it can attach the event handlers to the right things. So your on clicks, your on changes and stuff, it wants to know that it's putting it on the right DOM elements. There was render to static string, which didn't have any of those React IDs. But in order to do the attachment of the event handlers, we really need those. But now in React 16, they removed all of those. They're not there anymore. Now it walks the tree to figure out the correlation and tries to be pretty smart about how that works. So that kind of shaves off a lot of the response. And but they also introduced this new API called React DOM.hydrate that you have to use instead of React DOM.render in order to hydrate your client-side app with what was rendered on the server side. And it will give you an error if you use React DOM.render. It'll tell you that, hey, React.render is getting deprecated, and it's going to be removed in React 17, so switch over to React.hydrate. But the cool thing is that React.hydrate now gives us nice, helpful warnings if you do weird things and your server-side rendering doesn't match your client-side rendering. So if, for instance, somehow the contents of a tag is different on the server than it is on the client, like we have just seen with a bug that we found in our code, where server-side we were always rendering the wrong language. So it would render like in Portuguese on the server side and then be in English on the client. It will give this warning that says, hey, the text content doesn't match. On the server it was this, on the client it was this. Try to fix that. Or if the tags were wrong for some reason, it'll tell you that it expected to see this tag, but it saw this other tag inside of this container. Or if you have extra attributes on the server that don't exist on the client, it'll tell you that attribute that it saw. And similarly, if there are extra attributes on the client that were on the server, it'll say that this prop didn't match. So it gives lots of helpful warnings so that hopefully you don't shoot yourself in the foot with server-side rendering. We also saw this chart yesterday talking about the speed of React 16 over React 15. And it's comparing Node 4, Node 6, Node 8, and then recent Node 8.3, which shipped with this new version of V8 called Turbofan. So it must be fast. And what we're seeing here is that in the blue was React 15 raw, so uncompiled. And just by compiling process.env production in your app, you can see a 2x speed up. In Node 6, it's even faster, and so forth in Node 8. So confession time. So I built our server-side rendering in Eventbrite, and I forgot to set the process.env to production. And it went out to production. And it went out to production for 6 months before we realized it. And then I don't know who, I can't remember who found it. It may have been Kaylee who found the issue. And we put the process.env production in there, and we saw that 2x speed up just in our graphs. Like when we launched it, just went down like this. So this is legit. Like this actually happens, right? I did it for you as a proof of concept, so you know, right, that it's important that you should have that in there. Okay. So we're still running on Node 4 for random reasons, but next month Node 8 is going to be on long-term support. So we're going to jump over to Node 8. So basically, in a span of about maybe 8 months, we'll go from Node 4 uncompiled in the raw to compiled down to Node 8. So we're going to go basically from 241 milliseconds, as you can see there, down to 14 milliseconds, right? And that's like writing no code, optimizing nothing, just upgrading or setting the proper environment, upgrading React, upgrading Node. We're going to get a 20x speed up just from that. Like that's amazing that you can do that without writing code. So server-side rendering is going to be super fast rendering to string, but still it's not as fast. There's still some limitations, right? If you have a big page that you're rendering on the server side, it has to put that whole string into memory before it can send it in the response. And you're going to find that your servers are going to be dominated just by rendering to string because of it's very CPU bound or CPU bound, and you have to allocate all this memory for that string. So the best way to approach this is to do streaming. And now streaming has first-class support in React, which we heard from yesterday. So Sasha worked on React DOM Stream, which I actually saw your your GitHub issue, like, hey, we should get this into React a long time ago. And they were like, okay, we'll do it. And then they ended up doing it and implementing it, and now it's in there. So here's a kind of sample piece of code that you could use, like the base code you can use in order to implement it. So using node streams and React or render to stream, it'll start rendering out your markup to the client before it's even done. So painting can start happening before the whole app is rendered, which is super fast, and you get lots of performance gains from that. So the server features, though, I should let you know, are the last things that were built into React 16. So they may still be buggy. It's been in alpha for a long time, beta for a little bit, and then now recent RCs. So those things should have been caught, but if you find any errors, most likely it's going to be in the server-side rendering. Okay, now we've talked about changes to React packages, custom attributes, new return values, error handling, server rendering, and now the last one, the sixth thing I want to talk about is portals, which are pretty exciting, and apparently she's excited too. So let's talk about portals. So here I have this website on Eventbrite. This is the application I was telling you about, where you can browse a city and then find cool things to do in that city and then look at it. So here I was browsing Eventbrite, or browsing the Boston page we have here because we're here at React Boston, and start scrolling down the page to see cool things to do. This is all a React application, by the way. I passed all those popular events, keep going down because I'm trying to find something cool in music, and oh, hey, Barry Manilow is live October 3rd. So I click the share button, and here's that modal that pops up on top of it, right? And it pops up on top of the entire page. I don't want the modal to appear inside of the event card. All those little pods are event cards. I want it to appear at the top of the page. So now I'm trying to render something that's in a tiny event card that I want to exist on the top of the page. And that's something really difficult to do in React because you want it to exist outside of kind of the confines of the app. You want it to exist in the entire document. So we're not using React portals, obviously, to solve this. We're doing some other finagling to make this work. But React portals could really help us solve this problem, hopefully, really easy. So here's kind of a sample of that event card. So it has the state, show modal, and then show modal is false initially. And then when you click the share button there, it's going to call that handle share helper method, which will set the show modal state to true. And then it'll render out that modal and pass the shown prop, the state to that shown prop, so that it'll render the modal. And on the surface, it looks like that modal is going to be rendering inside of that event card, which we know we don't want because it needs to be globally on the page so we can have that nice background on it and it can appear on top of everything. So the way that we would could now implement the modal is using a portal component that I'll show in a second. But basically, when the modal is not shown, it won't be rendered. But when it is, it'll put all of its content inside of this portal component and then render out the dialog tag and all that other thing that's needed for the modal. Okay, so then the gist of it now is inside of this portal component because, like I said, we don't want the modal rendered inside of the event card. We want it to be a sibling of the entire app. So here's a very oversimplified portal component. So it's using this new API that exists on React DOM called Create Portal. And you pass two things to Create Portal. You pass the elements that you want and then where you want this thing to be rendered into. So Create Portal is a lot like Create Element in that it returns back an element, but instead of rendering it inline, I guess so to speak, it renders it where you tell it to render it. So that you can use it just like you would use create element. And this is a gross oversimplification because I'm not cleaning anything up. Like, you should have a component will unmount that will actually remove it from the DOM and things like that. But this is kind of the crux of it. And so it does depend on React DOM, which is unfortunate, right? So this code is not portable across different renderers. They have a little to-do comment in the code that says, figure out how to make this not depend on React DOM. So maybe that'll happen, maybe not. The API just became official 2 weeks ago. Before, it was called Unstable Create Portal, so it's just now become regular Create Portal, so it's there. There are absolutely no docs on it, like zero. I had to reverse engineer it from looking at the test to see how it actually worked. So that's why I have this oversimplification version, because I want to make sure I don't give any misinformation. Like, I know this part works, because that was in the test, but everything else, there'll be docs coming soon. That was one of the promise for when they're releasing React 16, is that they want to work on the docs. So check out those. Okay, so now what React Fiber, the kind of rewrite of the reconciler that then enabled all these additional features that I talked to that were in React 16, it also enables more renderers to exist. By separating out the reconciler, which figures out how to go from point A to B in an efficient manner, and then tell the renderers what to do, by having that separation, now it should be a whole lot easier to build all these renderers, because they can just focus on rendering the different places. So we know React DOM, obviously. We've heard of React Native, most likely. There's also React Sketch app, so that you can render React components in Sketch, which a lot of designers like. And I like too, so that the designers can't just move pixels around and all of a sudden create a new component. Like, there's going to be a one-to-one mapping between our design system and the Sketch files, so that when they build designs, it'll be using those components. There's React VR, React PDF. There's a whole list of here. I have 23 total listed here. Some really useful, some probably not. Like, there's React 3GS and other things like that, or React Word. So pretty cool things. Check out that repo, and you can see all of them listed there. So that's basically it for all of the features I wanted to talk about. There are a bunch of little things here and there that are in React 16, but these are kind of like the main things. And if you want to use React 16 now before it officially releases, most likely next week, you can use it this way by doing a yarn add React at next and React DOM at next. And that'll give you the latest RC, which is RC3 now. They say this is going to be the last RC. They're just kind of working on the documentation now. So hopefully with the MIT license, it's going to be released next week. It's actually really stable because, or at least it must be, because Facebook, if you go to facebook.com, you'll see that they're using RC2 in production. So they're just kind of working through various bug fixes. So provided that you've kind of addressed all the warnings that I talked about, you don't have any warnings in your React 15 app, upgrading to React 16 should just work. That was kind of the idea. They wanted it to be backwards compatible, so that they focused on backwards compatibility with this rewrite so that you could upgrade and not have to worry about anything. So that kind of async rendering that I was talking about, the prioritization, all those cool things, async scheduling, it's actually turned off in the initial, it will be turned off in the initial release of React 16. And then in future versions of React, then they'll provide a feature flag that will be defaulted off, but that you could actually turn on in future releases. So you won't be able to use that or leverage that. Initially, the focus was just on backwards compatibility. However, so if you can keep a secret, right, between me and you and the video and everything else, if you can keep a secret, I'll show you a way that you can, if you really want to, you can use async scheduling, a portion of it right now. So if you go into your node modules after installing it, okay, you go into React DOM, and you're going to find this JSON object that's going to say Fiber async scheduling false. Change the false to true, okay, manually or whatever, and then you can enable this unstable method API called unstable deferred updates. And what that does is that simulates the low priority updates in your in your code. So now you can wrap it around a set state, for instance, and that now becomes a lower priority. So if you made an API recall and then you want to do a set state, wrap it around that, and then it'll be a lower priority there. So you can kind of get a quick taste of what it's like. So this React Fibers resources did a demo. I tried it out as well, and kind of this is what it looked like before. This is the synchronous scheduling with Fiber async scheduling false. You can kind of see this is over a second, all this rendering that's happening in this kind of sample. So it's just taking up the JavaScript engine for a whole second and a half. So the rest of the browser is, or the interactions is not useful or not interactable. However, you turn React Fiber asynchronous scheduling on, and now you can see control is going back to the JavaScript engine periodically, so it can check to see there's other things to do. So we're actually like what Lynn showed in her diagrams way in the beginning, we're now seeing happening in the browser with this flag turned on. So you can try it out if you really want to. So Dan said this a few months ago, Fiber gives us an architecture that's flexible enough for many cool things, but it'll take a while to take advantage of it. So this is kind of setting the groundwork for what all the things they're hoping to build into React so that our applications can be more performant, can be more powerful. So I'm pretty excited about it. They've been working on Fiber since last July, so it's about a little over a year, and it's finally coming out. So that's kind of just the beginning of lots of cool things. And now that they've resolved all the patent issues that I barely understood anyway, like we're kind of free to go and kind of leverage this cool technology. So I have a bunch of resources here for you. You can read the React 16 RC where they list all the things that they're building. They've actually put the changelog in master now, so you can see all the new features that are happening there. They've released a couple of blog posts about error handling and the custom attributes, so you can read those, and then other links there for you to be there. So that's basically it. I wanted to kind of thank the React Boston team for inviting me here to give this keynote. This is actually the first keynote that I've ever given. It was kind of one of the things that I wanted to do, to be able to keynote a conference, so I can check that off of my achievements, I guess. So thank you to Andrew and Michelle and Marissa and the rest of the team for inviting me. And I don't know if you realize like how much effort it goes into having a conference and having a conference go well. There's so much preparation that happens before, and then stuff that's happening behind the scenes. Like right now, there's probably people running around with their heads cut off trying to make sure everything is going well. So I wondered if you could join me in giving a hand for all of the team, for all that they're doing. Yes. Yep. The first React conference in the Northeast, and hopefully from this reception, how this has been going, this will be able to continue. And then for you, thank you all for coming here at 9 in the morning on a Sunday to listen. Hopefully you learned a thing or 12, that would be great, as well about React Fiber, and that I was able to kind of inspire you and get you excited for what's to come, like what's in React. So I love to hear feedback, good or bad. Just let me know. You can pull me aside or send me a tweet or what have you. If anything didn't make sense, feel free to tweet at me or to find me afterwards, and we can chat about it so I can go into detail about different things. But you can find me on Twitter at BenMVP, go there, or shoot me an email, or I have this AMA set up so you can go and ask questions there if they're more detailed as well. And like I said, I'll be posting a link to the slides on my Twitter right after this, but they're already up on my website, so you can find it there. And with that, thank you very much. Enjoy the rest of the conference. Yep. So come find me if you got questions.
We can do a couple minutes Q&A if you want to. Like,
we can do a couple minutes of Q&A. Who's got questions? I potentially have answers. We have a question over here. Yeah, what you got?
Hi, we just tried to upgrade our app to React 16, and getting a lot of errors from dependencies.
Yeah.
Using things that are
Yes.
no longer functional. Do you have any tips for getting around that problem?
Yeah, so that's going to be the problem that you're going to see. So when you're upgrading from React 16 to React 15 to React 16, you're going to run into a bunch of errors, and that's what he's seeing with third-party dependencies. So things like Enzyme or other libraries that you're using. So I do know that Enzyme has been working on their own version of RC that will work with React 16. But a lot of other libraries that may still be using React.prop types, for instance, they're going to have errors. So that's going to be the biggest hurdle, is to get over that, is for those third-party dependencies to also upgrade to 16 so that you can. I don't know of any real way of avoiding it, because those libraries just have to be 16 compatible. They'll most likely say that they only work with 15, so that will be what will be holding you back, most likely, not your own code. But usually those third-party things, unless you're using a lot of third-party components and such, those third-party things will be like tooling and such. So your app could work, but the tooling would not. So I don't have any great solution, but except for to wait until those upgrade.
Right,
yeah. Yeah, you could submit a PR. That's a good idea, and help the maintainer, right? That's what we learned from Henry yesterday. Yeah.
Ben, I just had a quick question.
Yep.
You mentioned that with an error, the component, the app will unmount.
Yes.
But that's only if you don't use that error boundary
Correct.
component?
Yeah, so the way that you can avoid your app from completely unmounting is using the error boundary. That catches it, and then that error boundary will render out something. But if you don't, then yeah, the whole thing will unmount. Yes. Who am I going to? Right there? Yes.
Can you speak real quick to some of the issues you encountered with Webpack?
Oh, yeah. So it wasn't really related. The issues that we had, I mentioned that we tried to upgrade to React 16 and had Webpack issues. So we're on Webpack 1, and we have all these old loaders and stuff like that. So just the process of upgrading, and now I needed to use prop types, and there was just all these different things. I'm not quite sure all that it was. I think just things got deprecated over time and just didn't work. So I don't think it'll be that problematic. I was just hoping that I could just do that code mod and everything would work, and it didn't. But actually, one of my coworkers, Ryan, has already submitted a PR for us to upgrade from Webpack 1 to Webpack 3. So we should be good. I don't think it'll be that bad.
Let's take one more question.
One more question? Okay. You right there.
Just a quick question. React DOM Hydrate, is that just for the server side, or will that affect the client side as well?
So the question was about React DOM.hydrate. So that's just for the server side. So if you're rendering server side and you want your app to hydrate based upon what was rendered server side so that the client doesn't have to re-render on the client, then you use hydrate. But if you're just having your normal like create React app or just client side rendering, you just use React DOM.render like normal. Nothing would have to change.
All right, thank you, Ben.
Okay, thank you.
So we're going to go right into our next talk. It's a 30-minute talk, and then we'll have a coffee and snack break.
Okay.
Just make sure your name is right.
Yes.
Okay, here we go. I'm going to hand it over to Ari to talk about accessible components.
All right, thank you all for coming out. Can everybody hear me okay? Cool. All right, so first I'll tell you a little bit of background about myself. My name is Ari. I am the team lead for front end at a company called edX. You may have heard of us. We are a MOOC provider focused on providing high quality education to everyone. We're a nonprofit, a partnership between Harvard and MIT, and we are hiring. So if you're interested, follow up with me after the talk. So a little about our platform. Everything we build is open source. Our whole OpenEdX platform is all open source. So everything that we build is GPL, and all of the software we use to build our software also has to be open source. So can I just get a quick hand for the MIT license? Yeah, you have no idea how much of a relief that was for our team, but it really was. So our platform, because it's extended by a lot of our users, it needs to accept theming, it's highly customizable, it needs to be internationalizable as well, and it also needs to be accessible. So for us, kind of the first big sell for using React was the ability to encapsulate accessible functionality. And the work that we're doing on that is going to inform a lot of what I'm going to talk about today. So first, I'm going to jump into kind of a high-level crash course on web accessibility, then walk through some of the best practices for doing this using React specifically, then review some of the tools that you and your team can use to make sure you don't run into any like regressions, make sure your code is as accessible as it possibly can be. So web accessibility is a super, super broad field. I'm not going to try to tell you everything. I could not do it in 30 minutes. I probably couldn't even do it in a weekend. And furthermore, even if I did get into everything, it's probably not going to stick for you until you start putting it into practice yourself and seeing how it applies to the work that you do. So instead, I'm going to kind of try to point you towards the right resources. So when you start implementing accessible functionality yourself, you'll know where to go, where to find that information. So what is accessibility? I kind of like this particular definition. This is from our internal training course. And it defines accessibility as the degree to which a product, device, or environment is available to a person. This is intentionally broad. See, there's nothing in here about like your website has to work for blind people. That's not really what it's about. It's not about specific use cases. It's more about making sure that your product or application is available to everyone. So why should we care about this? Well, some companies, edX is one of these companies, have legal requirements to make their software accessible. edX specifically has an agreement with the US Department of Justice. If you work in healthcare or government, you may have similar legal accessibility requirements. Some companies do it for their bottom line. Right? Accessibility means you have more users mean more money. But really at the core, accessibility is about developing for people. We build software for people. But when you prioritize accessibility, you're making a conscious choice to include everyone in your user base, and that's really what we're here for. So we're all used to developing for the web. Developing for the web is great. You know, we've got our images, we've got our videos. We, the React people, are really into dynamic content, really kind of rich client-side experiences. And we all are used to it, and it's great. It works great for us. But option track or an audio description track. And for these really rich client-side experiences, the JavaScript-heavy stuff, it doesn't really work quite the same way if you're navigating through with a keyboard or you're using a screen reader. Fortunately, we have assistive technology that helps to sort of bridge this gap. And assistive technology, this term refers to the software and the hardware that people with disabilities can use to experience the same content that we do. This might include screen readers. That's kind of the broadest use case. There's also like speech input software, and then hardware like eye trackers or head mice, foot mice. There's all kinds of stuff out there that helps out with this. So cool, right? But you think, okay, do I have to build my application specifically to work on these devices? Like, can I compile React Native so that it works on a sip and puff device? And fortunately, the answer is no. You don't have to do that. all of these devices, all these accessible technology input devices, they're keyboard emulators. So as long as your application works on a keyboard, as long as it's navigable with a keyboard, then it will work here, which is great for us. As for the output devices, this includes like screen readers, captioning. It may involve hardware such as, this is a refreshable Braille display. Once again, you don't have to tailor your content specifically for these devices. As long as you have a textual equivalent to every bit of content that you're serving to your users, it will just work. Right, just work. That's kind of a dangerous phrase. So keyboard for input, text for output, right? We're done here, right? You all understand it? No. There's a little bit more to it than that. What about the specifics of implementation? So fortunately, the W3C, the kind of governing body of the web, puts out standards for us to follow. This is within the HTML spec. They also publish specs specifically focused on accessibility. And kind of the biggest one of these is the Web Content Accessibility Guidelines, also known as WCAG 2.0. This is kind of a rule book. It sets requirements, and it's also frequently used as a legal standard. So for edX specifically, our legal agreement around accessibility, we are required to meet the WCAG 2.0 standard. It's kind of like an API in that it tells us, the developers, how to build our content. It tells the browser how to implement it using the underlying accessibility API. And it informs the manufacturers and the developers of assistive technology, like these screen readers, like these displays and these input devices, how they need to interpret things. And the way we maintain compliance with the WCAG guidelines is through, there's this wonderful document, the WAY ARIA authoring practices. WAY ARIA stands for Web Accessibility Initiative, Accessible Rich Internet Applications. And that's standard speak for dynamic content. This is the kind of stuff that we're building with our rich client-side applications, our JavaScript-heavy stuff. So if you're building like a highly dynamic component, something like a drop-down or a modal, check the WAY ARIA authoring practices. All of this stuff is on w3.org. It's publicly available to anybody. And chances are your use case is reflected in there. They have extremely detailed sections around how to build button groups or tab panels. It's all in there. Instead of just trying to memorize it all right now, when it comes time for you to build a dynamic widget, check the document. Now, real quick, I'm going to run through some specific things that are good to know around web accessibility, some HTML stuff that you might kind of not be familiar with. ARIA attributes is a big one. This is the same ARIA that I just mentioned, accessible rich internet applications. ARIA attributes are special attributes that you can apply to your HTML nodes to apply additional semantic significance, right? So you can have your ARIA hidden, you can have ARIA live, ARIA described by, ARIA label. All of these attributes enable you to tell like a div or a span, hey, this content means this to the page, or it relates in this way to this other piece of content on the page. Roles are another similar attribute to the ARIA attributes, but they define more the broader purpose of an element. Roles can refer to like a header role, a nav, a main content, a side, etc. Learn about keyboard events. So WCAG and WAY ARIA define specific keystrokes to perform certain standard behaviors. So like navigating through a drop-down, for example, your arrow keys have to work. If someone opens a drop-down using the keyboard, they have to be able to navigate through it with the arrow keys. And there's tons of these. There's tons of these important keystrokes for you to know about. Implementing these requirements kind of helps screen reader users navigate navigate through the whole page. So it's important to make sure that your users are able to shift focus to the right areas of your page. Tab index will sort of enable you to enable or disable focus on particular elements. Use it in moderation. The specs define requirements around color contrast as well. So this applies to users with visual impairments such as low vision, color blindness. There are specific ratios that have to apply for text color contrast. You also shouldn't use color as a sole differentiator. So say like if an error message is red and the redness is the only way that you indicate it's an error message, someone with color blindness might not pick up on that. So it's good practice to also use, like, say, an icon to distinguish it as well. Right, so to boil all this down into a very glib set of steps, keyboard as input, text as output, make sure you follow the web standards set down by the W3C, and then hopefully Prophet. So with regards to React specifically, accessibility is something that the React core team cares a lot about. The React documentation has a specific section around achieving accessible React applications. I highly recommend checking it out. The biggest thing that I can advocate for here is to have a component library, right? So real quick show of hands, how many of you use modals in your applications? Right, yeah, pretty much the whole room. How many of you have more than one modal implementation? Yeah, yep, I see you. Yep, we do too. So this doesn't really scale when it comes to accessibility. If you have multiple modals, you have to make sure all of them are up to code. And this takes time, it takes developer time, it takes reviewer time. It's really a time sink. And companies can use component libraries. Frequently, they're used to encourage sort of UI consistency, but it's also an excellent way to isolate this complex accessibility functionality so that your developers don't have to go back and read through the spec every time they want to put a modal into the application. And frequently, too, best practices for accessibility extend to other things as well. These best practices help to make your application better for everyone. Focus management is a really big one here. So frequently, when we're doing dynamic client-rendered applications, we are often re-rendering the DOM, repainting, and most users don't notice and don't care. But if you rely on the keyboard to navigate through a page, and you're applying focus to these elements, and then the container re-renders, then you lose your place. And if you're visually impaired and this happens to you, it can be pretty disorienting. You don't know where you are after everything re-renders. If you were on, say, an input field, then you might be like somewhere else in the DOM. Kind of sucks. Here's a really simple example of how something like this might happen. We've got our lovely to-do list example, and you've got the focus outline applied to the input field here. Let's type into the input field. We'll hit enter to save. And then the entire list re-renders because the parent component is subscribed to the underlying data, the underlying list. So the whole thing repaints. Most of us wouldn't notice, but then we lose our focus. The focus is removed from the input field. So a better approach here is to only render what you need to render. So only render the new content that's coming in. Subscribe your entities to the underlying data at a more granular level so that you don't end up re-rendering stuff that you don't need to, and you don't have to worry about programmatically managing focus. Sometimes you can't avoid this, though. So if you do have to manage your focus programmatically, refs is the way to do this. Typically in React, it's considered kind of weird to mutate the DOM directly. It's not jQuery. Feels kind of wrong, but this is what refs are for. And if you read the docs on refs, they specifically call out focus management as a use case. And if you're going to do this, call focus in component did update, which fires after render. So once your DOM repaints, then focus will be applied to the appropriate place. Sometimes it's appropriate also to implement focus traps. So like for a modal, you might want your user to either save or close in order to get out of the modal. It's the same kind of thing that would happen to any of us if, say, we visited a blog and they really wanted to push their free ebook on us. You know, you have to acknowledge the modal to advance to the next step. There's multiple ways to do this. You can mess around with ARIA attributes, ARIA hidden, do crazy stuff with tab index. Ultimately, I think the easiest way to go about implementing focus traps is to hook into keyboard events. There's a lot of excellent demo components out there that demonstrate how to do this in a good way. React accessible modal, I think, is an excellent example. Another big one is, so a lot of us build single page apps and do dynamic routing on the client side. So if you are doing that, you're presumably re-rendering part of the page and changing the route. And all the work we do here to avoid the full page refresh, it's nice and it feels a lot smoother, but it actually makes things a lot harder for screen reader users. So like say, use case here, say you tab all the way down to the bottom of the page, you click a link in the footer. The footer doesn't change, the header doesn't change, but the content in the page re-renders. But the user is still stuck down there in the footer and they're not aware that the page has re-rendered. They're not aware that they're essentially on a new page. So the best way to sort of get around this, make sure you're updating your document title. React document title is a good way to do this. Shift focus back up to the top of the page. If it's essentially a new page sort of experience for your users, shift focus back up. That's what would happen if it was a hard page refresh also. And it's typically good practice to have an ARIA live element somewhere in the page that will just say navigated to whatever page, to a screen reader. Sighted users, users that are not using screen readers, will not see this at all, but it's a sort of a good courtesy for the folks that are. All right, so this kind of goes back to the reasoning behind having a component library. We want to trust our development teams to do the right thing, but we're humans, right? We make mistakes. Everybody makes mistakes. It's a whole lot to ask to make your whole development team read through specification documents every time they need to change something. So if it is possible for us to automate or abstract away some bit of functionality, some bit of like complicated markup, we should absolutely do that. So here's kind of a use case for that. We've got like an input field with a label, with an error message, and descriptive text too. And so this example uses prop types. Obviously, if you're using like Flow or TypeScript, then you would apply your own logic here. But we have, we're applying a required label to this component. So labels are required. This is one most people are familiar with. Every input field needs to have a label, and the label has to be linked up with that input field somehow. We could say that the description and the error message are requirements also. This might not apply to all your use cases, but we use it too. And this is what the generated output for something like this might look like. So a lot of the linking these things together is handled by IDs. And these IDs aren't semantic, and it kind of sucks to have to generate them every time. Like if you're a developer, you need to make sure your input field has a unique ID. Okay, like what am I going to use as this unique ID? That then needs to be maintained. And because they don't have a whole lot of semantic meaning, it's okay for us to abstract that ID generation away and do it in either like a parent component or a higher order component. Use those IDs for, say, for the input itself, for the error message, for the description, to link all of this stuff together. And so we have a higher order component within our component library that handles this for inputs like a select input, a text input, a checkbox. We want all of those to behave kind of the same way. We want them all to have required labels. We want them all to display error messages and description in a consistent way. So higher order component is a good use case for that. You could wrap it in a parent component too, but if you want to get into more complex stuff like binding handlers, binding on change or on blur handlers to the input element itself, an HOC is a good solution. Okay, cool. So now let's jump into ways that you can make sure your code, once you've written it to be accessible, stays accessible. So the testing pyramid for accessibility quality is a little bit different because accessibility itself is kind of a strange beast. It still requires some degree of human verification. So that's why we have the sort of manual acceptance testing and the code review in here. Some organizations keep like an accessibility expert on staff who does all of the accessibility code reviews. Or you might just make your developers do it too. But it is important to integrate this human step into the process. So the bottom of the pyramid is linting. So I love linting as a way to catch accessibility errors because it will call them out before you even have a chance to commit them. So some of you might use this. It's part of the Airbnb ESLint plugin, ESLint preset plugin, Airbnb. I can't remember what it is off the top of my head, but we use it. So who can tell me what the accessibility errors are with this bit of markup, if you can see it? No alt. Yes, that is the obvious one. There is a second one here. Does anybody know what it is? Yes, exactly. Wow, I did not think anybody would know that. Yes, it is a non-interactive element, and an event handler was bound to it. So this is the kind of thing in a code review that you could really easily skip over, unless you're Evan. I wish I had you on staff to review my code. Yeah, it picks up stuff like this that might slip through the cracks. Unit tests, this one's obvious. Test your code, test the accessible functionality, prevent regressions. I'm not going to beat this dead horse any more than it needs to be. My slides are a little out of order. Yeah, so with regards to the linter, it can be a really powerful tool for teams that might not have that broad accessibility knowledge. Your developers get immediate accessibility feedback on their errors, and it becomes part of their workflow and helps them start to internalize these rules and these best practices. If I get that non-interactive element error, I might go Google it, start thinking about it, and it also reduces the strain on the domain experts to constantly be reviewing the code and correcting the same errors over and over and over. So dog food your code. We do this, like, even if you're a TDD person, if you're a front-end developer, generally speaking, you're going to see how your code looks in a browser. It's just what we do. It feels good to see your code in action and know that it's working. And we can extend this to accessibility use cases as well. It's a lot easier than you might think. So going back to the keyboard, if you can navigate through your application using only the keyboard, just try this. Try getting rid of your mouse for an afternoon and seeing what it's like to browse the web using just your keyboard, or browse your application using just your keyboard. If you've tabbed through a form, it's a lot faster than constantly moving your hands from the mouse to the keyboard, right? So it's faster, it can be faster, and it also has a side benefit of making you feel like a cool keyboard-only hacker. I know you all probably have custom key bindings set up in your editors and your terminals. Why not browse the web this way as well? So use a screen reader. Do not do this right now because your computer will start talking. But if you use OS X, it comes with this software built into it, VoiceOver. It's OS X's native screen reader. There's a little bit of a learning curve to start using it, but essentially it will read through UI for you. And if you do this, then you can experience your application the same way a screen reader user might. Windows has its own NVDA, there's JAWS, and then Linux has Orca. It's sort of similar, it runs full page audits, tells you where you went wrong. So that leads me to audit automation, which is another way to sort of prevent regressions at a larger scale. These are tools that will interpret your rendered DOM, go through it, read through everything, and then flag any accessibility violations that they catch. This may be, oh, your color contrast is not high enough, or you use this weird ARIA attribute and you're not supposed to use it that way, etc. There's a huge industry of consultants who will bill you for this, but there's also some wonderful open source tools out there that you can kind of build into your CI process and flow to prevent regression. Browser extension, there's Axe Core and also React Axe. React Axe is tailored specifically to React. It's great, renders your code, tells you where the accessibility problems are. Google Lighthouse is another good one. It's a little bit more full-featured, but there's plenty of other great ones out there. All right, so ultimately, React is an excellent framework if you want to build accessible applications, because accessibility is a core part of the React ecosystem. It's a high priority for Facebook, and it's a high priority for the community as well. There's plenty of great open source tools out there built around making sure your code is accessible as possible. It's easy to implement accessibility upfront as long as you're reading through those specs, if you're following the documentation, you'll be fine. And if you have good regression testing, you'll be okay. But it's harder to retrofit, and that's kind of the broader use case here. That's what we ended up having to do at edX, go back and retroactively add accessibility to a lot of our code. But sometimes you have to do it, and so these tools can help you. Again, I'm going to push the component library. That's a really powerful thing. And web accessibility really benefits everyone. When you build it into your application, there can be huge performance payoff, usability payoff. If your application complies with standards, it'll be more maintainable, and you'll broaden your user base. We all are developers. We tend to sometimes get bogged down in implementation details, technical stuff, editor holy wars. But ultimately, we're people, and we're building software for people. So let's make sure we're doing it for all people. Thank you. Do we have time for questions? Okay. Yes.
So you talked briefly about unit testing, and I wonder how you would go about doing that. Would you just test that, like, you know, the rendered HTML has the appropriate properties, or is there some deeper way that you can test the accessibility component?
So the question was around testing accessibility through unit tests, unit tests for React, it's good to test the behavior. Like for a drop-down menu, you might want to check that opening it with the keyboard works, navigating through it with the keyboard works. As far as does it have the right markup, that's a better thing to do in either snapshot tests or to leave up to the auditing tools. You don't have to say, does this element have this attribute? That's kind of not really a useful test. It's more, because it's a broader thing, it's easier to leave to sort of higher level automation. Anyone else? Yes?
Some of the keyboard shortcuts, or just kind of sticking to plain keyboard navigation?
So that's a good question. The questions around enabling keyboard shortcuts versus sticking with the vanilla keyboard navigation in the browser. And for like 99% of your use cases, you should stick with the vanilla browser navigation. Keyboard shortcuts, if you're doing like a really highly dynamic widget, if you've got like a drag and drop, then you might want to implement some custom keyboard functionality around that. It's generally a good idea to see if other folks have done something similar, just to make sure you're not reinventing the wheel. Anyone else? Yes?
Do you need best practices for how to structure like the ARIA Live thing we talked about earlier?
Question is around structuring the ARIA Live. Did you mean for the like the routing changes? We don't use client-side routing in our application just yet, so I don't feel like I can have a super strong opinion about it. My recommendation would be have an element at the top of your page, at the top of whatever section gets re-rendered, and make that ARIA Live. When you update the route of your page and the middle part sort of re-renders, update the text in that ARIA Live element and shift focus to there, because it'll be up at the top of the page, and then the user will be able to tab through as well. But other folks may have different opinions on this too. All right. Oh, one more?
Yeah, one more.
You said that
That's good.
that an important part would be use a good component library. Do you have any recommendations for good accessible component libraries, or
I don't know.
You write yourself?
I would love to recommend the one that we're building, but it is not anywhere near close to being done yet. For broader use, I mean, I can recommend specific widgets. There are like React Accessible Modal is a good one. And then a lot of it is custom too. Like your application will probably have CSS associated with it, and using like an existing component library out of the box for behavior might not have the functionality you need around styling. Yeah, I'm not really sure of any component libraries that are flexible enough to allow for that. If anybody else knows of one, though, I would love to hear about it.
All right, let's thank Arya again. So we're going to a break now. Two quick things. We're a little short on water bottles. More are coming in about an hour. We do have water coolers, and there are cups next to them, so feel free to use those. And then second, we do have our VR demo set up in the back. Feel free to hit that up during the break as well. And we'll see you guys back here in a little bit.